Hello everyone and welcome back. My name is Mr. Kovault, and in this video I'm going to go over the law of multiple proportions. So in a couple of other videos, my previous videos, I went over the law of conservation of mass, where I talked about how Lavoisier had determined that during all reactions mass is conserved. So the mass of your reactants is always equal to the mass of the products. And we also talked about how that supports the atomic theory that all matter is made up of elements or atoms, because if everything is made up of atoms and atoms are not created or destroyed during a reaction, then they're just rearranged. And so we can see that in the law of conservation of matter or mass. Then in another video, I went over the law of definite proportions. And there, instead of looking at the conservation of mass, we looked at how the ratio of the masses of elements that make up compounds stays the same. So the composition of a compound does not change. So regardless of where you get your water from or how you make water, water is always going to have a ratio of masses of hydrogen to oxygen of 8 to 1, and that's always going to be the same. So, what about the law of multiple proportions? The law of multiple proportions is a little bit different and it's a little bit tricky to kind of understand. So, I'm going to kind of walk us through it. So, first of all, the law of multiple proportions was established or I guess discovered, if you will, by John Dalton. So this is around 1804. Again, this is all happening along the same time. So Proust was around like 1798 or somewhere around there, and I remember Proust was the one who came up with the law of definite proportions, or was the one who established it. And then you had Lavoisier in like 1786, 1789, somewhere around there. And he was establishing the law of conservation of mass. So this is all happening about the same time, and this is all giving support to the atomic theory. So what did John Dalton discover? Well, he discovered that when two elements, we'll call them A and B, elements A and B, when they form two different compounds, right? So A and B are going to react to form two different compounds. Both compounds have both A and B in them, and just A and B. Or, if we have a third element, it could be A, B, and C. But the idea is that you have two compounds, both of them contain A and B together. So in that case, the different compounds here, we're looking at the masses. It says the masses of element B that combine with 1 gram of element A can be expressed as a ratio of whole numbers, small whole numbers. Well, what does that mean? That's kind of a mouthful. So again, let's go over this again. When two elements, call them A and B, we have two elements and they form two different compounds. So we have two different compounds, both of them have A and B. So now, if we talk about the law of definite proportions, remember the law of definite proportions was where we were looking at the ratio of the masses between A and B, right? So if I have a compound made up of A and B, I'm going to look at the ratio of the masses of A to B. And that's going to stay the same no matter how much of the compound I have or where it came from and anything like that. So that was the law of definite proportions. Remember, the ratio between A and B stays the same. It's a definite proportion, same proportion throughout. Okay, so what about multiple proportions? Multiple means many. So here we're looking at multiple proportions of a compound. So instead of looking at the ratio of A to B, we're looking at the ratio of B to B between two different compounds. So we're not looking at the ratio of A and B in one compound. We're looking at the ratio of the mass of the same element in two different compounds that are made up of A and B. Okay, so that's the difference between the law of multiple proportions and the law of definite proportions. So I hope that clarifies it, but if you still need clarification, I have an example. So here, I have two compounds. They both have carbon and oxygen. So we'll say that carbon is our element A and oxygen is our element B. They're two different compounds because they have, oops, excuse me. Sorry about that. So these are two different compounds because you can see that they both have different amounts of oxygen. So this has carbon and oxygen in it. This has carbon and oxygen in it, but they have different amounts of oxygen. So they're different compounds. But they're both made up of carbon and oxygen, A and B. Okay, so we want to look at the amount of one element with respect to a certain amount of the first element, of the other element. So we want to keep this element the same, right? So that's why we're saying 1 gram. So we want to look at how much oxygen combines with 1 gram of carbon to make carbon dioxide, CO2. So here, the mass of O2 that combines with 1 gram of carbon is 267 grams. So that's the mass of oxygen that is bounded to 1 gram of carbon. Okay, so we have the mass of this oxygen that binds to 1 gram of carbon. So what about in this compound here? Here, the mass of oxygen that combines with 1 gram of carbon is 123 grams. So we got the mass of oxygen that binds with 1 gram of carbon for carbon dioxide, and we have the mass of oxygen that binds with 1 gram of carbon for carbon monoxide. So what the law of multiple proportions is telling us is that the ratio of the masses of this atom here, the oxygen, is going to have a whole number ratio. And so if we do a ratio here, you can see that we have 267 grams of oxygen from the CO2 divided by 123 grams of O2 from CO, right? We got a ratio. We can simplify this because it's very obvious that this here is going to have a ratio here, or it's going to form a pretty close ratio there. And so I need to make this clearer. So that should be a 3. There you go. So my 3 was looking more like a 2. So if you look here, so if I double 133, I get 166 or 266, which is very similar to 267 here. So this is basically 2 to 1. So a whole number ratio, small whole number ratio, 2 to 1. And that is what the law of multiple proportions says. So this would be applied to all compounds that have elements, the same elements, but they differ in the amount of one element versus the other. And so that, ladies and gentlemen, is what the law of multiple proportions is. I hope that was helpful. I hope that clarified any confusions with regard to how this is different from the law of definite proportions. If you like this video, if you learned something from this video, then please, by all means, like the video. Hit that like button over there. Share the video with your friends. Also, make sure you subscribe to my channel. Hit that notification bell. And when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section so that way you can be you can let me know what you think, and you can ask me questions, and I can help you with anything you need help with. I would love to hear from you. Thanks for joining me, and have a great day.